ChemSpec is a high-fidelity chemistry platform built to simulate chemical reactions at both the molecular and microscopic levels. Beneath its easy-to-use interface is a carefully engineered reaction system that turns complex chemistry into something students can clearly see, understand, and explore. We begin by selecting the elements or compounds that we want to react. This can be done directly from the periodic table. For example, clicking twice adds 2 potassium atoms. Clicking reactant once removes a single atom, while pressing and holding clears it complete. Students who know a compound by name rather than by formula can simply type its name into the reactant box. Entering water, for example, allows ChemSpec to identify and add the correct compound automatically. Once both reactants have been selected, ChemSpec analyzes them using an extensive system of established reaction families. The engine determines whether the substances can interact, identifies the most appropriate reaction pathway, and calculates the resulting chemical changes. When a reaction extends beyond the local engine's validated library, ChemSpec can turn to Codex to investigate further, explore additional possibilities, and help the student continue without reaching a dead end. Students can then watch the reaction unfold at the molecular level. ChemSpec shows every bond that breaks and forms, explains each stage of the transformation, and presents a balanced chemical equation alongside it. This helps students connect the equations they see in class with the molecular events those equations represent. The reaction is then brought to life through a high-quality 3D laboratory simulation. Accurate equipment, realistic color changes, and carefully modeled reaction events allow students to experience the experiment as though they were carrying it out themselves. Once the simulation is complete, ChemSpec provides a detailed breakdown of the product molecules, including their structures and how they were formed. Codex can then explain the principles behind the reaction and help students explore its applications in areas such as medicine, energy, industry, and everyday life. ChemSpec also supports organic chemistry through its organic molecule drawer, allowing students to construct and explore a wide range of organic structures and reaction pathways. They can investigate how changing conditions affects a reaction, including processes such as the electrolysis of ionic compounds in aqueous solutions. For users who are unsure where to begin or simply want to experiment, the randomize button generates a reaction from a library of validated compounds. The local mode supports more than 2,000 reaction combinations, while Codex mode expands its capability far beyond the limits of a fixed reaction database. GPT 5.6 Sol and Codex were also central to ChemSpec's development. They helped us define the requirements, plan the architecture, implement features across the Rust codebase, redesign and visually inspect the interface. Repo documents, decision logs, Git history, visual comparisons, and dedicated smoke builds preserve this process and show how each major feature was planned, reviewed. Codex is also built into the finished application, but within carefully defined. It can propose a structured reaction or possible mechanism when the local systems cannot confidently resolve one. While ChemSpec remains responsible for the chemical structures, balancing, valence rules, atomic mapping, and simulation, every proposal must pass through the same deterministic chemistry engine used for offline reactions, and anything that fails those checks is rejected rather than animated. ChemSpec brings together chemical reasoning, molecular visualization, equation balancing, and laboratory simulation within a single platform, making complex reactions clearer, experimentation more accessible, and chemistry far more engaging to explore.